In perpetual darkness, Jurassic seafloors teemed with life. Despite extreme conditions and perpetual darkness, it was home to unique and specialized organisms that thrived in this environment, adapting to the scarcity of resources and absence of light. Imagine being lowered into these abyssal waters today. You'd see nothing but mud and decay, no fish or plants anywhere. In the Mesozoic era, particularly during periods like the Jurassic, similar deep-sea environments covered much of Earth's surface, stretching from pole to pole. And yet, life found a way, with organisms such as giant squid-like cephalopods called ammonites and small benthic creatures thriving in these dark depths. Subject: the Jurassic Marine Dead Zone passage to fact check. But here's the kicker. This dead zone actually tells us more about prehistoric ecosystems than anything else in the fossil record. How? Because the creatures that lived there helped feed terrestrial animal populations, including dinosaurs, back on land. Let me explain how it all worked. First off, we have these giant marine reptiles, plesiosaurs and ichthyosaurs. They were like the whales of their day, ruling the open seas with their massive size and predatory prowess. These creatures would cruise through the prehistoric oceans, catching fish and squid to fuel their metabolisms. But here's a secret: most of what they caught didn't get eaten. Their waste dropped right into that dark abyss below, feeding an entire food chain of deep-sea organisms. Now picture this. You're down there on the seafloor, covered in sediment and nothing but darkness around you. It feels like another planet. And then, something incredible happens. These ancient crabs start to move in. They have claws that look like scissors, perfect for cutting through tough tissue. Fossil evidence shows these crabs would scavenge anything they could find, thriving in the Jurassic seas around 150 million years ago. But wait, there's more. Giant clams called rudists also thrived down here. You've probably seen pictures of these creatures growing in reefs during the Cretaceous period, but the ones on the deep seafloor were different. They didn't form colonies like corals. Instead, they lived solitary lives and burrowed into the sediment to find food. So you have all this organic matter dropping from above, feeding those crabs and clams. But here's where it gets really wild. Some of that waste wasn't just fish guts or squid bodies, it included dinosaur poop too. Yeah, you heard me right. Dinosaurs back on land would eat plants, then their waste got washed into the ocean by rivers and streams. This process was especially significant during the Jurassic period, when vast river systems transported terrestrial organic matter to coastal marine environments, supporting diverse marine ecosystems. Now think about this for a second. These crabs and clams were literally living off dinosaur crap millions of years ago. And here's the kicker. We know this because scientists found microscopic bits of plant material in those clam shells, which can only come from dinosaur diets on land. It's like finding an ancient breadcrumb trail leading straight back to Tyrannosaurus rex territory during the late Cretaceous. So how did all this end up mattering? Well, it turns out that studying deep-sea creatures from the Mesozoic era gives us a window into the diets and environments of dinosaurs themselves. By understanding the ecosystems and food chains of these marine organisms, we can infer what resources were available on land and how they influenced dinosaur diets. And that's huge. But here's where things get even stranger. As you dig deeper into the fossils from this dead zone, something starts to emerge, a pattern in how these creatures lived. You see, some of them had really thick shells or exoskeletons, like tiny tanks rolling around in mud. Why? Because they were defending themselves against contemporary predators, such as marine reptiles and fish, creating a unique survival strategy in this harsh environment. Now imagine being one of those crabs scuttling along the seafloor during the Jurassic period, looking for scraps to eat. Suddenly, a giant toothed fish, such as Leedsichthys or Romulusaurus, darts out of the darkness and tries to grab you. Those tough shells and claws gave them an edge, making it like having armor in a war zone. But wait, there's more. Some of these deep-sea creatures also had remarkable adaptations that allowed them to survive in environments with little light and scarce food. They developed bioluminescence, meaning they could produce their own light. Picture a sea full of tiny glowing lights, each one a creature trying to stay alive in utter darkness. Now here's where it gets really wild. Scientists are finding more and more evidence that these deep-sea creatures played a crucial role in recycling nutrients back up into the ecosystem. By feeding on organic matter that sinks from above, they helped maintain the cycle of life, ensuring that vital nutrients were returned to upper levels, keeping everything fed and thriving. So how does this connect to dinosaurs? Well, let's take a step back. Imagine you're a dinosaur on land, munching away at plants during the Jurassic or Cretaceous periods. Your waste ends up in rivers and eventually out to sea. There, ancient crabs and clams sift through it all, eating what they can and recycling nutrients back into the system. It's like a giant, interconnected food web that spans from land to deep ocean, supporting a vast ecosystem across different habitats and time periods. But here's where things get even more fascinating. Some of these deep-sea creatures actually made their way into shallower waters too. Fossils of crabs with tough exoskeletons have been found in coastal areas, suggesting they ventured out from the dark depths to explore new habitats. Now think about this. If these critters could survive in both deep and shallow waters, what does that mean for the ecosystems they inhabited? It suggests a complex network of interactions between various marine organisms across different environments. And it paints a picture of an interconnected world where every part played a role, from the top predators to the tiniest scavengers. So let's circle back. Why do we care about this dead zone in the deep ocean? Because studying it helps us understand how ancient ecosystems and prehistoric creatures, including dinosaurs, functioned millions of years ago. It's like piecing together a giant puzzle. Each piece is crucial, even if it seems small or insignificant on its own. But here's where things get really mind-blowing. Scientists are discovering that these ancient deep-sea creatures weren't just passive recyclers. They were active participants in shaping their environments. Think about crabs and clams breaking down waste. They weren't just cleaning up messes. They were changing the chemistry of the ocean floor, making it more habitable for other life forms. This dynamic interaction highlights how these ancient marine organisms played a crucial role in maintaining the health and diversity of deep-sea ecosystems. Now imagine this. You're a scientist studying these deep-sea fossils from the Jurassic period, trying to piece together how life connected back then. You find evidence that shows these marine creatures played a critical role in maintaining biodiversity and stability within their underwater habitats. It's like discovering the missing link between ancient marine ecosystems and understanding the complex web of life during this time. But here's the clincher. We still have so much left to learn about these ancient marine environments. Every new fossil discovery adds another piece to the puzzle, painting a clearer picture of life in prehistoric seas and on land millions of years ago. And with each new detail, our understanding of dinosaurs and their contemporaries deepens too. So, as you continue exploring these ancient waters and their bizarre inhabitants, think about how everything connects, from those massive marine reptiles patrolling the open ocean to the tiny scavengers thriving in the depths of the sea. It's a reminder that even the most unlikely places can hold secrets waiting to be uncovered. And here's what it all means. By studying this dead zone, we're not just learning about ancient marine life. We're gaining insights into how entire oceanic ecosystems functioned and evolved over millions of years. It's like unlocking the past and seeing the world in a whole new light. So next time you look at pictures of dinosaurs or see one of those giant marine reptiles, remember this. Their stories are intertwined with strange creatures that lived deep below the waves during the Mesozoic era. In the depths of ancient seas, bizarre and resilient life forms thrived in perpetual darkness, showcasing nature's adaptability and the interconnectedness of Earth's ecosystems throughout time. Now let's take it one step further. Imagine if we applied what we learn about these ancient ecosystems to today's world. How do modern oceans function? What secrets might they hold, waiting for us to uncover them, much like the long-lost deep-sea creatures of the past. Studying the Jurassic marine deposits, often referred to as dead zones due to their low oxygen levels, is crucial for understanding past environmental changes and the resilience of ancient ecosystems. These areas provide vital clues about how our planet's oceans functioned millions of years ago and help us comprehend the delicate balance necessary for supporting life in aquatic environments today. So here's the big question. If we could travel back in time, would you want to see this ancient world for yourself? With its giant marine reptiles patrolling the open waters and bizarre scavengers thriving in utter darkness, it's a place where every creature played a crucial role in an interconnected web of life. And that's what makes studying these deep-sea fossils so thrilling. In the late Cretaceous period, massive marine reptiles like Mosasaurus ruled the seas, while strange deep-sea dwellers such as giant squid-like creatures and bioluminescent fish thrived in the darkness. Imagine gazing into the depths of ancient Jurassic seas. These dark abyssal waters reveal a foreign yet crucial world, holding vital clues about Earth's past and potential futures. So next time you're curious about dinosaurs or marine reptiles, remember, they're part of an interconnected web of life that spans continents and oceans. While dinosaurs ruled the land during the Mesozoic era, diverse marine reptiles like ichthyosaurs and plesiosaurs thrived in the seas, contributing to a rich ecosystem where life flourished despite environmental challenges. And now that you know this, think about everything else out there waiting to be discovered. Each fossil, no matter how small or seemingly insignificant, is a crucial piece in reconstructing Earth's ancient past and revealing the diversity of life that once roamed our planet. So keep exploring, because who knows what secrets are still hidden in the depths. Imagine those dark abyssal waters teeming with creatures you've never even imagined. Think about giant plesiosaurs like Elasmosaurus gliding through the darkness, their long necks slicing through the water like a submarine periscope. These animals were giants of the deep, yet they thrived in an environment where sunlight never reaches during the late Cretaceous period. Then there's the ichthyosaurs, marine reptiles with flippers and dolphin-like snouts. Picture them hunting in packs, using echolocation to detect prey in the pitch-black depths. Their sleek bodies were streamlined for speed and agility, making these apex predators of their time rulers over a world that was as alien as it was interconnected. And let's not forget about the ammonites, shells spiraling outwards like ancient space stations. These shelled cephalopods were incredibly abundant during the Jurassic period, making them nearly synonymous with this era. Imagine finding an ammonite fossil and envisioning a creature navigating the ancient seas millions of years ago, its shell providing a window into the bustling marine ecosystems of that time. Each of these creatures played a critical role in their Jurassic ocean ecosystem. Plesiosaurs fed on fish and smaller reptiles, while ichthyosaurs preyed upon squid-like animals and other small marine life. Ammonites served as homes for countless tiny organisms. Every part of this web was essential, from the tiniest plankton to the largest predators. So next time you dive into a pool or stand by an ocean, think about those ancient marine creatures from the Mesozoic era. They're a testament to the incredible resilience and adaptability of life on Earth. And who knows what secrets lie waiting in the unexplored depths. It's a reminder that every piece of the puzzle matters, no matter how small. Keep searching, because you never know what mysteries are lurking below the waves.